You're listening to The Solution, a podcast by Growers Mineral. I'm your host, Russell Bobel.
So this is our third episode of our soil microbes series. If you missed the first two, you can go back and catch our episodes on the foundation of soil microbes and bacteria and compare them to this fungi episode. I'm Marguerite Fall. I've been with the company almost a year and have a passion for geology and environmental science. So this was a perfect company for me to work for to merge all of my interests.
My name is Jim Hubbeisen. I'm Director of Research for Growers Mineral Corp. I've been with the company full-time since 1994. Farms that we farm have been on the growers program since 1955. What I bring to the company is a little technical expertise. I've got my bachelor's and master's degrees from South Dakota State, and then been farming full-time since 1975.
My name is Zach Smith. I am Canadian, live in Kitchener, Ontario. My background is in environmental studies. I went to university, bachelor's degree for 5 years for that. I've worked with growers under Jim, assistant to Jim, for 3 years now. It was beginning of 2017. I've grown a lot in passion for agriculture, and it relates quite nicely to what I learned in my education as well. I've been able to apply that quite nicely as well. So it's a constant learning experience.
We're talking about fungi today. Zach, do you mind giving us a quick introduction into what fungi is and how it fits into the soil microbes ecosystem? For
sure. So to start, I'd like to lay the foundation again that I've laid before, which is that soil microbes should have a stable population, a stable population, but not a static one. The difference there is stable is that there's no immediate threat to their survival. Static is that it's always the same, and that is not the case. Their populations should not always be the same, especially not across wide areas. The second point is that just like in a forest or the ocean, a lake, you name it, the populations and their relationship with one another in the soil are like a food web. It's very interactive. There's predator-prey relationships, there's symbiotic, there's parasitic relationships. All of those are important to a healthy ecosystem. If you unbalance any one of those, you're going to unbalance the others. So that's a simple foundation I'd like to lay first, because that's very important to a proper understanding of how this ecosystem works. Fungi themselves they fill somewhat similar roles as bacteria, especially in the decomposition and having a symbiotic relationship with plants. Any farmer will also know there are pathogenic fungi. I'm not going to go into much detail with those. It's not really important, I think, to what we're talking about right now. Fungi typically are far more numerous in a forest ecosystem than they are in an agricultural field. The reason for this is that they are much better suited to breaking down difficult to break down materials such as lignin and cellulose. Those products are found mainly in woody plants, so trees, obviously, other small plants in the forest, whereas in an agricultural field, you don't typically find many woody stems that are breaking down. Bacteria are better suited to breaking down the easily broken down materials that you'll typically find in an agricultural field, which makes them more numerous. That said, fungi is still very important in an agricultural field. You certainly want to cultivate a healthy environment for it to grow there, which is typically done the same way that you would cultivate a healthy environment for bacteria. That is to get oxygen in the soil, to get rid of toxicity. And they work together. So we can go into two different types of fungi. I don't know if you want to do that now, Marguerite, or at another time.
Tell us about the different kinds. I know you said there were two main types that you talked about in your article, right?
Yeah, so the first is decomposer. And as I said before, it kind of fills not the same niche, but a similar one to bacteria. So these are the fungi that are going to be breaking down detritus, dead material. And you could argue that they actually do a more effective job of it than bacteria, only because fungi can cover a much wider area. So I think anybody that's ever stuck a shovel in the soil a few times has brought up a shovelful, and you'll see little white strands through the soil. That's not roots. Those are called mycelium. And mycelium is the visible part made up of hyphae, and hyphae are made up of single-celled, like fungi are single-celled organisms. So they come together, many of them form hyphae, and that forms mycelium. And that's actually how they cover a much wider area in the soil. So what they'll do is, like a bacteria, for example, it's easy to explain this stuff when you compare bacteria and fungi. Bacteria is not mobile in the soil. It's so small, it spends its entire life, which is very short, very many generations in the same spot in the soil. The only way that it gets moved is by hitching a ride on something, being blown by the wind, or if you cultivate and smooth the soil around, stuff like that. Fungi will form these strands that'll actually go out and seek what they need. So it'll seek out water, it'll seek out dead matter, it'll just seek out new areas that don't have the competitive pressure that other areas will. And so by being able to do this, they're able to access a lot more dead matter than bacteria would. Another way, and this also speaks to why there's more population of them in forests, it's how they can break down tough materials like lignin. So you have a tree dies, falls in the forest, nobody hears it, and it lays on the forest floor. There's certainly bacteria on it, but because they're immobile and they can't break down lignin, they're pretty much screwed if they don't get in past the lignin somehow. Fungi aren't limited by that. Their mycelium can actually seek out little holes in the lignin and enter through those. And so that's why they primarily break down those woody structures. And once they're in there, they can release enzymes that can actually break down lignin. Bacteria are limited in that sense. So that's why they're important to breaking down woody materials. That's also why they're better able to access a larger area.
So Zach, I have a quick question. I'm sorry to interrupt you, but on the subject of them being, as decomposers, and the comparison that in a farm field, that you are farming versus a wooded area, that the quantity of bacteria would be much higher versus fungi because it's the more useful decomposer in that type of situation, right?
That's right.
On that subject, if I'm looking to start a farm and I have a wooded plot of land, and maybe you have some thoughts on this too, Jim. How does that work if I'm looking at a wooded plot of land and I know that it does not have the soil type, the soil quality, the correct soil microbes in it? How do you start to change the food web and the ecosystem of that soil to make it conducive for farming?
That's a good question, Marguerite. And to answer it, I'll go back to what I originally said. We don't want to forcefully change those things necessarily. That ecosystem exists there for a reason. And even though it's built around a forest ecosystem, I mean, first, okay, if we go back 200 years, 300 years, even 100 years in a lot of areas, 50 years sometimes, people were still clearing land, right? My great-grandfather cleared a patch of forest by hand, all on his own, I think in the 60s. So that was forest being converted to agricultural land. Now back then, he probably didn't actually know much about soil microbes. He certainly farmed in a way that was better for them, but he didn't know much about them. But so if you do clear that land, you're at first going to have a higher population of soil fungi than you will bacteria. I'm not saying that an agricultural field needs to have higher bacteria population than fungi. I'm just saying that because of the conditions present there, it better suits the bacteria, so their population grows. It lesser suits the fungi, so their population, I don't know if it shrinks per se, but it doesn't grow as much.
But over time, so it happens over time. Yeah.
Yeah, and that's the point I'm trying to get at here. We shouldn't be trying to force change on these things because we think that we can change it for the better. What we should be doing is providing the best environment for growing conditions. Now, if you clear a forest, you need to get rid of all the stumps, the roots, yada, yada, yada. You're going to have a lot of detritus left over, more than likely, which is not a bad thing. And then as the years go by, that's going to get broken down more and more and more, and the field's going to start to resemble one that's been under cultivation for many years. As you're doing that, the population of the soil microbes is going to change to better suit what you're using it for, but it's going to change naturally.
Right.
It's not going to be forced by bug in a jug or some other treatment that I in my opinion, doesn't work.
Right. Jim, I saw you smiling over there a moment ago. What are you smiling about? What's your input on this?
Yeah, no. Zach's correct. In other words, in the forest, you have a lot more solid material that needs to be disintegrated. But you have that in row crops too. Like if you grow a very voluminous corn crop, there's a lot of starchy material, the hemicellulose that has to be broke down. So you still need a certain population of fungi in that scenario to just degrade that down so you can get your next crop planted in there. So your idea about changing it is true because bacteria will contribute to nutrients like nitrogen to the plant, which you want more of. But again, you don't want to totally discount the fungi either because of what they can contribute to your farm ground also.
Right. So have you ever done anything like that in your farming, Jim, where you've converted a plot of land that was so different soil-wise and then made it an agricultural plot?
And
what was your experience with how much time it took for the soil to be correct?
The soil will work pretty good right away, but your contribution to the plant is a little bit weaker because of this imbalance of bacteria and fungi. But as you, and Zach's right on when he says that you want to create an environment that's superior to the biology and then let the biology decide how fast it wants to convert. And if you've got a good physical environment, that biology will adjust very quickly to the plant that it has there because the plant will talk with the microbes and tell them, well, I got to have more of these guys and I got to have more of those, and they'll make the adjustments. See, the studies on that have become very voluminous because in human medicine, they're trying to figure out that interaction between your immune system biology and dealing with systemic disease like cancer or heart disease and that type of thing. And they're trying to manipulate those microbes to attack the invader. And see, out in the soil, what we want to do is get the microbes to adjust to the crop we want to raise, basically. So we're letting Mother Nature make the decision, and we're not, Zach, saying you don't want the bug in the jug and shove it in there because we don't know exactly what we do need. We want Mother Nature to make that decision for us.
And it's not something that happens over such a long period of time that you would need to, I need to farm this land this season, so I've got to throw these bug in the jugs in. I mean, the soil should adjust pretty quickly if you create the right conditions for it, right?
Mother Nature's she has a lot of wisdom that we don't give her credit for, really.
Yeah, absolutely. So, Zach, I didn't mean to interrupt your train of thought, but that was very interesting little side note. But I know that you were telling us about decomposers is the first type of fungi, and then the second type is the mycorrhizal. So
good job, you got it.
It's a tricky one to say. So tell us what is that one?
So these are more closely related to the symbiosis in bacteria. It's the same idea. They live within a symbiotic relationship with the plant. I'd argue that they're more effective. Like their main role in their symbiotic relationship with the plant is the nutrient one, where they'll seek out water and nutrients that they can bring back to the plant via their mycelium, and then in return the plant will give root exudate, which is a starchy substance, a sugary substance that the fungi can feed on. So that's their main symbiotic relationship. There's others, of course, like preventing sickness, preventing pathogen. So they'll signal when there's an unknown type of fungi that's entered the root zone, and then the plant can activate its defenses before it's invaded. But the main role I'd like to focus on for mycorrhizae is their nutrient relationship with the plant. And again, they're more effective at this than bacteria because of the mycelium network. So bacteria certainly do this as well, but they're limited by their mobility. They can only access those nutrients that are in their immediate area. Now you have a much larger population of bacteria, so by definition, they will cover a larger area. But the fungi are able to reach out with their networks and access, let's say, water or nitrogen and phosphorus, and then bring that back to the plant. So what you're essentially doing by having a healthy mycorrhizal fungi network is you're increasing the surface area of the root system. So that's the biggest benefit.
And did you say too that the fungi was aerobic or anaerobic?
Very important topic, especially for growers. Yes, most fungi and the types I've described so far are aerobic. They require oxygen in order to live, essentially. And so you can actually quite heavily influence the fungal populations in your soil by influencing the oxygen availability. So this is a way, going back to your question, Marguerite, about clearing a plot of land and what you can do to try to make it, get the beneficial microbes in there as soon as possible. Provide oxygen. If you have locked up soil that's anaerobic, you're going to get probably some anaerobic fungi, and they will break things down, but anaerobic decomposition is far slower than aerobic. So not really in our timeline. That, and it produces a lot of acid. If you can get that oxygen in there, you're going to get much faster colonization by soil fungus, as because of their mycelium, they're able to colonize a broader area than bacteria. And they're going to do their job better too. So the mycorrhiza and the decomposers, they both require oxygen. So as a grower, for growers, I'm going to put a little plug in here. And by growers, I mean that with a lowercase g, not an uppercase. You do want soil fungi in your fields. And in order to have that and healthy bacteria, you need to get oxygen into the soil. You need to get it deeper than the top 2 or 3 inches as well.
So Jim, can you kind of elaborate on that? I know I've heard you talk before about why getting oxygen in is so important, but why is it so important, and why is it really part of our growers program? Why is that so important?
Because like Zach was saying, the most beneficial fungi, the most beneficial bacteria are all aerobic in nature. So the ones that help the plant grow the best, like a well-aerated environment. And see, if you get a lot of rain, that makes it anaerobic. So you got to get the water conducted through there. So anything you can do to improve the oxidation within the environment is going to give you the types of populations that are most beneficial to the plant. And see, we're back to the same mechanism that we talked about before. As we create an environment that is beneficial to the ones that help us the most, that allows us to grow the crop more efficiently, because they're forming that symbiotic relationship. The plant's feeding them and they are feeding the plant. So as you create that oxidized environment, you get the microbes that tend to form the symbiosis with the plant, and they'll work back and forth together. So Mother Nature's actually helping you grow the crop at the same time, which is what your goal is. Because once you do that, a couple things will happen. Your input costs will start to drop significantly, and then the quality of your tissue will start to improve significantly also. So it's feed value for whoever consumes it, whether it's an old cow or your son eating a vegetable. They will feed their immune system much better with the product that has been grown in accordance to the way nature designed it.
So it's more nutritional.
Yes, absolutely. Mm-hmm.
So I would say that it sounds to me like what you're talking about with the oxidation is so second nature to you guys. Mm-hmm. You clearly really know what you guys are talking about. So I will say what you just said was a little confusing to me, because how do you create more oxygen in your soil? I don't know. What are the tactics that you do to do that?
Farmers have always used the tactic of tillage. The very first tool that John Deere invented in the late 1800s, early 1900s was the moldboard plow. And the moldboard plow physically upends the soil, which introduces more oxygen into the profile. At growers, we talk a lot about using high calcium lime. The chemical relationship on the electrical activity of your soil will automatically introduce more oxygen into the profile also. And so that's why we talk a lot about calcium, because we think it's the introduction of oxygen to create the proper environment to give you the beneficials that will help feed the crop.
Zach, do you have any additional feedback, or Jim, any final thoughts?
On the fungi, another point is that those filaments, the filament nature of fungi is very important. Like Zach said before, it expands your area where the plant can draw nutrients from, because the fungi can actually grow into the roots themselves, and the roots accept that because the nutrients that the fungi is eating, it can pass right along to the plant too. So you can increase your surface area to absorb nutrition and water by very large factors, 10,000 times higher, through that filamentous nature of the fungi itself.
Yeah, I'd actually like to add on, or not add on perhaps, but benefit from what Jim just said. I don't want to understate the importance of the mycorrhiza fungi. It's vital to like 90% of plant life on the earth. These relationships really help plants survive in a massive way. So don't underestimate how important that is in an agricultural field as well. Don't ignore it. Don't think you can control it either. That's outside of our realm of power, but we can do things to positively or negatively influence it. And given how important it is, we need to positively influence those relationships.
That's great. That's great, guys. Thanks for joining us today and teaching us more about fungi.
Thanks a lot, Marguerite. Thanks, Jim.
Thanks for listening. If you enjoyed what you heard today, please subscribe and share with a friend. If you'd like to learn more about the Growers Program, visit our website, www.growersmineral.com.
What background do you have in mind specifically?
Me?
Yeah.
Well, specifically with them, hey, I'm Jim Hallbeisen. I'm Director of Research here at Growers. Been here since 1927. Whatever it is.
Thanks, Russ.
That's pretty close.
I thought Russ liked me.
Did we get that recorded?